Hi, this is Kumarave. In this lecture, we are going to discuss about FDMA downlink analysis problem. So now let us consider a problem statement. So we have given the satellite transponder as a bandwidth of 36 megahertz. So we have the data given is bandwidth of an transponder which will be equal to 36 megahertz. Then the next data is EARP is given, EIRP equivalent isotropic radiated power, which is 27 decibel watt. Then they gave G by T ratio. G by T ratio is equal to 30 decibel per Kelvin, right? Gain in terms of decibel, temperature in terms of Kelvin, therefore decibel per Kelvin. Then they are given total link loss. Therefore, next data what they gave is total loss equal to 196 decibel. Okay, then they give transponders accessed by an FDMA carrier each of 3 megahertz bandwidth. So again they give bandwidth of each is 3 megahertz. They give output back of 6 decibel output back of PO represent back of which is 6 decibels. So they gave 6 parameters: bandwidth of the transponder, EARP, G by T ratio, losses, bandwidth, and backoff. Okay, so here, so except the bandwidth, okay, except the bandwidth, rest of the parameters they gave in terms of decibel, so we can substitute directly. But here bandwidth they have not given in terms of decibels, so we need to do some conversion. So now look into the data given. Okay, so this is what we have stated so far. So the data given is bandwidth of the transponder, that is 6 megahertz. Okay, then EARP, then GT, losses, and everything they have given. Okay, so now, so the rest of the parameters they gave in terms of decibel, but this transponder bandwidth and carrier bandwidth they are given in terms of megahertz. Now we need to convert this in terms of decibel equivalent. So how we can do it? So we know it, right? 10 log of 36 megahertz, that is 36 into megahertz, therefore 10 to the power 6, whose equivalent is 75.56 decibel hertz. Similarly, this carrier band with 3 megahertz also can be converted into decibel using the same formula. 10 log of 3 into 10 to the power 6, okay, which will be equal to 64.77 decibel. Okay, now let us consider an carrier to noise ratio for downlink. So the equation is carrier to noise ratio for downlink equal to EARP G by T ratio losses K. Here the K represent Boltzmann constant. Okay, then BT represent transponder bandwidth. Okay, so we know that Boltzmann constant whose value is 1.38 into 10 to the power minus 23, okay, joule per Kelvin. Again, so we will represent this in terms of decibel equivalent because all the values we have in terms of decibel, so we will convert again Boltzmann constant also in terms of decibel. Therefore we will take 10 log of 1.38 into 10 to the power minus 23. Okay, Therefore, we can substitute all the value in this carrier to noise ratio downlink equation. EARP, it is given as 27 decibel watt. So 27 directly we substitute. Then G by T 30. Then losses 196. So here negative side. So minus 196. So now Kelvin, if we take the logarithmic of it, we will get the values in terms of negative. Okay, that is minus double to 8.6. Okay, then minus of minus become plus here. Okay, then finally the transponder bandwidth. Transponder bandwidth we have already calculated, it is 75.56 decibel. Therefore 75.56 decibel. Then if we add these together, then we will have 14 decibel. This 14 decibel is nothing but what? Our carrier to noise ratio for downlink. So in the question they ask us to calculate the downlink carrier to noise ratio for single carrier operation. So we have completed this, and they also ask us to find the number of carriers which can be accommodated in the FDMA system. So now we need to proceed with this second portion of the question, right? So in order to find the number of carriers which can be accommodated in the FDMA system, the equation is K equal to alpha plus bandwidth of the transponder minus bandwidth of the carrier. Okay, so now here alpha is nothing but what? Alpha is equal to negative of back output back off. So in the question it is given whose value is 6 decibel output back off. Therefore, we can substitute here. Okay, here. So it will be back off is 6 decibel. Therefore, here minus sign. Therefore, minus 6 plus transponder bandwidth. So we know it. It is 75.56 and bandwidth of the carrier, that is 64.77. Then we will get, so the number of carrier that which can be accommodated in the FDMA system. So here it is represented in terms of, so here we are getting in terms of decibel, but now we need to find it. So actually this is nothing but what? Decibel equal, that is 10 log of K equal to 4.79 decibels. So now what we need? We need the value of K in this equation. So in order to find K, what we have to do? We need to divide this 10. Then we need to take what? Inverse logarithm. If we do so, then we'll get K equal to 10 to the power 4.79 divided by 10, whose value is approximately equal to 3. Therefore, the number of carrier required is 3. Okay, thank you.